All right, so how did everybody do with hypothesis testing with probabilities? So hopefully that went fairly well for everybody. So the last thing I want to show you is it turns out that you can actually use your calculator to do full-blown hypothesis tests without kind of all the steps and stuff. So I still would encourage you to do all the steps, and I would really just probably encourage you to do this as a check because again, I kind of prefer the ways I showed you originally, but I hate to not show you that there's a feature on your calculator that'll actually do this for you as well. So again, you still have to know how to set it up. So you still need to be able to do steps 1, 2, 3, and 4 and stuff like that, even to be able to put it in the calculator. But it kind of gets you the answer a little bit quicker and stuff like that. But again, if you're a visual person like I am, I like to see the number, the normal curve drawn out. I like to see the shaded region. And you will see, like on my calculator, it'll actually show you, which is kind of cool, that the app I'm using. But I think the calculator you guys are using, it doesn't actually shade it in for you, which is kind of unfortunate. So let me show you how to do this. And then what I've got is a whopping 24 practice problems here. And so everybody's going to be responsible for doing one of these and then over the weekend kind of recording themselves solving it and then putting it up online to share with the class on Monday. So there's a bunch of these guys. So there's one for everybody. So I don't know how you guys want me to do it. If you want me to assign them, if you want to pick them. Maybe I'll just assign them this time since there's 24. So look for a number tomorrow in class where I'll assign you a number to actually work on and stuff. And again, so you want to show all 4 steps. You want to explain what you did in the video. So if you have questions about it or anything like that, just let me know. All right, so let me dive in. So these are actually the same examples I've already done in the previous section. So I'm just going to do them now using like the new calculator tricks that we can use. And so again, these are all going to break down in terms of whether sigma is known, sigma is unknown, or it's a probability. So that's going to kind of determine which hypothesis test we're going to choose. So this is the one from sigma was known, I think. So we've got the social scientist suspects that the mean number of years of education for adults in a certain large city is greater than 12. They surveyed 100 adults, found the sample mean to be 12.98 with a population standard deviation of 3 years. So again, before you can do anything, you still can't do a hypothesis test unless you're able to lay out the mu's and stuff like that. So this one, just to remind myself, this is going to be sigma known. And so again, what I'm looking at is my mu is greater than 12, which means my H naught is going to be mu less than or equal to 12. And then again, my sample mean, which I'm going to need to know, is 12.98. And my population standard deviation is 3 years. Oh, and my n is 100. That's important too. So the command that we're going to actually use for this is, lo and behold, what's called the z-test. So remember we used z-interval when we were looking for the confidence interval. Now we're going to use the z-test to look for to actually test this hypothesis. So let's go over and find z-test on the calculator real quick. So the good thing is z-test is in the same place where the intervals were. So if you just hit the stat button and then go over to test, so the very first one on our list is actually z-test. So this is the one that we want to work on here. And so if you notice, just like we did with z-intervals, we had a choice of we could either do data, which means we could put a bunch of numbers into the list and it would do the hypothesis test for us, or we can actually plug in, what the population mean is, what the population standard deviation is, what the sample mean is, and what the n is. And then what we're going to see is we're going to get what the z-value is, and we're going to get the p-value. So we're actually going to get kind of 2 measures of what's going on to see whether this seems reasonable or not reasonable. So again, with mine, I think we had, what was the mean? Well, now I forget the total problem, so let me go back. Oh yeah, 12 and 12.9. I got it now. So our sample, or our population mean is going to be 12. And then our population standard deviation was 3. Our sample mean was 12.98. And so notice in this case now, mine's kind of off to the right hand side, but if you notice, what you've got is we've got a not equals, a less than, or a greater than. So notice mine actually shows the graph and kind of shows you whether it's a one-tail or a two-tailed test and stuff like that. So at the moment I've got it set for a two-tailed test, which I don't want because I know my mu was greater than, so I want to set it for an upper one-tail test. And then my n, I think, was 100. And so notice it kind of disappeared off the chart here. So because before my n was so small, this allowed like the probability to be over there. So let me make sure I got everything typed in right because I keep talking. Yep, I got it in there. Good. All right. So in this case, so my z-score I can see is 3.266, which is going to be way over here somewhere. It's going to be way over here on the right. And my p-value is 5 times 10 to the negative 4, which means it's going to be like 0.00005. So it's definitely smaller than alpha. So this seems like, yes, this is definitely a reject H naught. I can go ahead and write it up and all that good stuff. And so yours will look a little bit different than mine. Like it may not show the picture and stuff like that, but it should have all the different commands. But you do want to make sure you click the right one because, like, for example, if I click the not equals, well, that one would still actually work, but that's not actually what I was trying to test. Or if I check the less than or equal to, you can see that my probability is like not even close to working. This would be a fail to reject. And not because it was wrong, it's because I clicked the wrong inequality. So you do have to know in advance which inequality to use and stuff like that. All right, so let's go back, look at the next example and the next calculator command here. So example 2, so this is the one we just did today. So this was the one where our sigma was unknown. And so this was the one where the orange and the the orange and the brown M&Ms were not that much different or anything like that. So again, let me write down everything I know. So my sample mean was 18.5. My population standard deviation was, or sample standard deviation was 2.4. My n was 24. And I think that's it. So again, the alpha was 0.05 in this case. But again, we're just comparing it to the p-value. We don't have to put the alpha into the calculator. So again, my H naught is going to be mu equals, 18. My H1 is going to be mu not equals 18. So again, for this one, what we want to use is t-test, just like t-interval, because again, sigma's unknown. So for the majority of the stuff that you're going to do, if you're using this command, it's usually going to be t-test for the most part, because again, it's going to be very rare that we know the sigma. So, all right, so let's go plug this into the t-test and see what we get. So let me hit done. So t-test is right under z-test. So if I go to stat, test, the number 2 is t-test. And so again, this has the same option. I can do data or I can do stats. So again, since I'm doing the not equals, I want to go ahead and click that right away. So I'm done with it. And so in this one, my population mean is 18. My sample mean was 18.5. My sample standard deviation was 2.4. And so you can see this is a nice two-tailed test. You can see the picture showing up. And then my n was 24 in this case. And so you can see my green section is kind of shaded in there pretty far. And so you can see my t-value is 1.02, which I think is the same t-value we got. And then our p-value was 0.138, which again was the same p-value we had found before. Since we're comparing this to alpha, we can see that unfortunately we're actually living, in kind of not this green area. So this would be a fail to reject H naught, just like we had found before. All right. And so again, I think this command is cool. I actually would not use it probably other than to check my work though, honestly. I mean, I'd still go through the big steps I was doing before because I find that to be a lot more useful. I think this is better as just a way to check your work and make sure you've done it correctly. That's me personally. I can't really judge you guys or, or actually know what you're doing, but that's how I would do it if I were you guys. All right, so lastly, let's do the probability one. And so again, this is the, eat orange M&Ms, earn an A, hopefully. So this is going to be our probability, or proportion, I guess. Let me be proportion instead of probability, but. And so again, just to highlight some stuff in here. So earn a grade greater than 90, surveyed 24 students, found that 22 of them had A's. So again, writing everything down. I've got my X equals 22. My N equals 24. So my P hat, I think, was 0.917. Which I think you don't even have to calculate, which I think is even cooler. Because I think you just have to type the N, X and the N in. But I'll write it down here just in case. And then our Q hat, which again, I don't think you have to calculate this either, which is the other nice thing about this command. So now let me write down my claims. So P is greater than 0.90. P is less than or equal to 0.90. And let's see, let's check it out. Oh, I forgot to write down. So with this one, we're using one prop Z test. So instead of one prop Z int, we're using one prop Z test to actually test it out. So again, the names are almost exactly the same. So, and again, this lives in the same area. So if we hit stats, test, number 5 is one prop Z test. And so, yep, so I'm right. You actually don't even have to type in the P hat. So our P naught is our 0.9. And so in this case, I want to do greater than. So I want to pick the one to the far right. And then our 17 was a 22, and then a 24. And so in this case, notice it gives us exactly our z-score of 0.27221, which I think is what we had. And our p was 0.39, which definitely seems about right. And our p hat was 0.9167 in this case. So again, the probability is bigger than 0.05. So again, this would be a fail to reject H naught. So it looks like we did everything okay on this one as well. So, all right. So that is pretty much the whole section in this case. So this is all of the first part of hypothesis testing. So the goal is for, so practice these 6 practice problems for today. And then I'm going to assign you one of them that you should start working on, as soon as possible. Record yourself actually, solving it out this weekend. So keep practicing it. Be ready to have it uploaded on Monday. So if you guys have any questions or anything like that, I'll be around all day tomorrow. So good luck.